And I saw this on the screen and I thought, well, first and foremost, I'm an artist. So I thought this was really beautiful and I wanted to figure out how to print this. Now, I'm a little bit of a weirdo in terms of my background. As an architect, I started to see that there were issues um, in cardiology that went far beyond just modeling. And in architecture, these were problems that we had solved a long time ago. And so I started to look at ways that the technology that I had could start to solve, in things that we had solved in architecture that were very easy, could help to solve some of the issues in pediatric cardiology. And I found out that, one day I walked in and there was a gentleman named Alex Barker, runs the Advanced Imaging Lab, and he was figuring out how to get four-dimensional flow, um, the actual blood flow and velocity in the heart. And I saw this from MRI. And I saw this on the screen and I thought, well, first and foremost, I'm an artist. So I thought this was really beautiful. And I wanted to figure out how to print this. We've got this weirdo printing technology called voxel printing technology that allows us to capture things in ultra high resolution right from um, imaging. And so we were able, over 6 months, work back and forth and figured out how to be able to take this work, this data, and transform it into a physical model. This work led to some early cases of single ventricle outlet, where you really want to understand what kind of intervention you're going to make, what the impact is going to have, and what the long-term ramifications of your intervention is going to have on the heart. More recently, this work has led to fetal MRI work. Barker has figured out how to get 4D flow in utero, to be able to do surgery in utero. And so it's been wonderful to be part of the team to try to figure this out. We've been taking this 4D flow and printing it in all kinds of different forms to both study the science of it, but also to study the ability to do the surgery.